The phenomena and noumena of Kant describe the planet Earth as a three-dimensional body, the phenomenon, and as a six-dimensional body, the noumenon. However, to this must be added the idea of scale. If Kant had introduced the idea of scale into his arguments, then many things that he wrote would have been deemed more valuable. This is the only factor that he lacked, and with this starting point, it is possible to find much that is new and unexpected in that which we think we already know. With regard to space, the first fact we come upon is that space is much too readily accepted as homogeneous. The very question of the possible heterogeneity of space never arises. If such a question ever arose, it was only in the domain of purely mathematical speculation, or science fiction, and never passed into the concept of the real world, from the point of view of heterogeneous space. Even the most complex and metageometrical views assert themselves each to the exclusion of the others: spherical space, elliptical space, space determined by the density of matter and by the laws of gravitation. Finite and yet limitless space. In each case, this is the whole of space, and in each case the whole of space is uniform and homogeneous. W. K. Clifford, 1845–1879, wrote in his book, Common Sense of the Exact Sciences, that the danger of asserting dogmatically that an axiom based upon the experience of a limited region holds universally, will to some extent be apparent. It may lead us to overlook, or when suggested at once reject, a possible explanation of phenomena. The hypothesis that space is not flat, and again that its geometrical character may change with time, may or may not be destined to play a great part in the physics of the future. Yet we cannot refuse to consider them as possible explanations of physical phenomena, because they may be opposed to the popular dogmatic belief in the universality of certain geometrical axioms, a belief which has arisen from centuries of indiscriminate worship of the genius Euclid. This may have a connection with the idea of the heterogeneity of space. The mollusk described by Professor Einstein may be able to move by itself, to expand and to contract. The mollusk can be unequal to itself, and heterogeneous with itself. This is, however, still an analogy, and a timid example of the way in which space can and should be regarded. Behind this example, in order to make it possible, the whole arsenal of mathematics, metageometry and new physics, along with the special and general principles of relativity, are necessary. Nonetheless, in reality all of this could be done more simply, if only the possible heterogeneity of space were understood, taking space as we took motion, from the point of view of direct observation. The space occupied by the house in which I live, by the room in which I am now, and by my body is perceived by me as three-dimensional. This is certainly not a pure precept, for it has already passed through the prism of thinking. But as the three-dimensionality of the house, the room and my body do not give rise to argument, it can be accepted. I look out of the window and see a portion of the sky with several stars in it. The sky is two-dimensional for me, it looks flat. My mind knows that the sky possesses depth, however my direct senses do not tell me so. On the contrary, they deny the truth of it. Now, if I were to reflect upon the structure of matter, and on a unit such as a molecule, then one molecule has no dimension for the direct senses. But by reasoning, I come to the conclusion that the space occupied by a molecule consists of atoms, protons and electrons, all having 6 dimensions, 3 space dimensions and 3 time dimensions. For otherwise, if a molecule did not possess 3 time dimensions, then its space dimensions would be unable to produce any impression on my senses. A great quantity of molecules produces on me the impression of matter, possessing mass only because of the 6-dimensionality of the space occupied by every molecule. Thus space is not homogeneous for me. The room is 3-dimensional, the sky 2-dimensional, and a molecule has no dimension for my own direct perception. Atoms, protons and electrons have still less dimension, but owing to their 6-dimensionality, a multitude of molecules produces on me the impression of matter. If the molecules had no time dimensions, then matter would be emptiness for me. In discussion therefore about the cosmos, it can be stated that man could be described as the microcosmos and organic life on Earth as the tritocosmos. Furthermore, it can be pointed out that each cosmos experiences time in a different manner, or on a different scale, which can then be associated with breath, where in this context, a unit of breath is equivalent to a unit of time. Man, in a normal state, takes about 20 full breaths, that is inhalations and exhalations, to the minute. A full breath therefore takes about 3 seconds. Sleep and waking are then regarded as the breath of organic life on Earth, where for man and for all organisms living in similar conditions to him. Even for plants, a full breath is represented by a 24-hour cycle. Sleep and waking are in this manner regarded as breathing for organic life because plants when asleep, that is at night, exhale, and when they are awake, which is by day, they inhale. In exactly the same way for all mammals, as well as for man, there is a difference in the absorption of oxygen and CO2 by night and by day, in sleep and in waking. Reasoning thus, it is logical to arrange the periods, or cycles of breath, then of sleep and waking in the following manner. Applying a simple rule of 3, we can divide 24 hours by 3 seconds, giving 28,800. Then by dividing 28,800, day and night cycles, by 365 we get close to 79 years, which represents the lifetime of man. The parallel can be continued further. Again, multiplying 79 years by 30,000, rounding it up, we get a little less than 2.5 million years. Then multiplying 2.5 million years by 30,000 we get a number of 11 figures, 75 billion years. So far, these figures appear to be logically possible with 2.5 million years for organic life on Earth and 75 billion years for the planet itself. However, later there are cosmoses lower than man, so let's examine how they stand in relation to this. Taking two cosmoses to the left side from the microcosm, and understanding by them first comparatively large microscopic cells, and then secondly smaller, admissible, almost invisible particles. Such a division of microorganisms into two categories cannot be said to be accepted by science. However, if we think of dimensions within the micro world, then it is impossible not to accept that this realm consists of two worlds as distinct in themselves, as the world of people and comparatively large microorganisms. 24 hours would then represent the life cycle of such a cell, and although the period of life of an individual cell can in no way be considered as established, science has revealed that for a specialized cell, such as those of the human organism, the period of life appears to be approximately 24 hours. The breath of this cell then equals 3 seconds, which tells us nothing yet. However, the 3-second lifespan of a particle tells us a great deal, and it indicates above all why it is so difficult to see these particles, although by their size, they should be accessible to vision with a good microscope. Working with these figures further, we see what would happen if we took breath, that is 3 seconds, and divided it further by 30,000, giving 1/10,000th part of a second. The period of duration of an electric spark, and at the same time the period of the shortest visual impression. For convenience in calculating and for clarity, 30,000 is taken instead of 28,800 and the coefficient rounded up. 4 periods that appear to be connected with, or separated from one another by one and the same coefficient of 30,000. The shortest visual impression. Breath or period of inhalation and exhalation. The period of sleep and waking. The average lifespan. At the same time, each of these periods appears to denote a corresponding, but lower period in a higher cosmos, and a corresponding but higher period in a lower cosmos. Taking this further, we can attempt to make a fuller table and bring into it all the cosmoses, to add 2 more of the lower ones. The first of which is the molecule and the second an electron. Then again, for clarity, when multiplying by 30,000 we can take only round numbers, and only 2 coefficients, 3 and 9. Thus 2,500,000 is taken as 3 million. 75 billion is taken as 90 billion. Then 79 as 80 and so on. The coefficient of 30,000 may appear too big, but at the same time remember that the relation of one cosmos to another is as 0 to infinity, and in the presence of such a relation, no coefficient could be too big. The relation of 0 to infinity is the relation of magnitudes of different dimensions. Every cosmos is 3-dimensional for itself, which means that the next cosmos above it is 4-dimensional for it and the one below, 2-dimensional. The next one above that 5-dimensional and the next one lower, 1-dimensional. One cosmos in relation to another is a magnitude of a greater or a smaller number of dimensions. However, there can only be 6 dimensions, or with 0,7. But by this table, 11 cosmoses are obtained. At first glance this appears strange, but only at first glance, because as soon as you take into account the period of existence of any cosmos in relation to higher cosmoses, then the lower cosmoses disappear long before reaching the 7th dimension. Take for example man in relation to the sun. The sun appears as the 4th cosmos in relation to man, taking man as the 1st cosmos. However, man's long life, 80 years, is equal in time to 1 electric spark for the sun. 1 shortest possible visual impression. Each cosmos is an animate and intelligent being. Each cosmos is born, it lives and then it dies. In one cosmos it is impossible to understand all the laws of the universe, however 3 cosmoses taken together, include in themselves all the laws of the universe. Or 2 cosmoses, the one above and the one below, determine the cosmos that stands between them. by passing in his consciousness to the level of a higher cosmos, a man, by this very fact, passes to the level of a lower cosmos. Here in each word lies a clue to the understanding of the structure of the world, however there are yet many clues to grasp. How then does movement from one cosmos to another appear, and where or when does the movement disappear? In what relation would the figures stated in the table stand to the more or less established figures of cosmic movement? As for example the speed of movement of the heavenly bodies, the speed of movement of electrons in an atom or the speed of light and so on. When you begin to compare the movements of various cosmoses, you get some surprising correlations. For example, for Earth the 24-hour period of the rotation on its axis is equivalent to 1/10,000th of a second, for man that is the speed of an electric spark. It is doubtful therefore whether at such a speed the Earth would notice its rotation on its axis. If man rotated similarly, then rotation around the Sun would occupy about 1/25th of a second, the speed of a still photograph. Taking into consideration the enormous distance that the Earth has had to traverse in this time, the inevitable inference is that the Earth could not be conscious of itself as we know it, that is, in the form of a sphere, but that it must be conscious of itself as a ring, or as a long spiral of rings. The latter is the more probable, using a definition of the word present as the time it takes to draw one breath, which is what comes to mind when time is defined as breath. Starting from this we could say that breath may be regarded as a unit of time, that is to say for direct sensation, the period of one breath is felt or perceived, as the present. Supposing then that the sensation of self, that is of course one's body, is connected with the sensation of the present, then we come to the conclusion that for the Earth, with one breath in 80 years, the sensation of itself should be associated with 80 rings of a spiral, circumnavigating the Sun. Passing to the lower cosmoses, that is to the cosmoses in the table that stand to the left of man, we can see in the first of them, an explanation of what appears to be the astonishing speed, almost instantaneous, with which some of the inner processes of our organism work. A man who gives thought to questions of physiology may not be astonished by the fact that the effects of drinking a cup of coffee or a glass of brandy, or the inhaling of the smoke from a cigarette, can be felt immediately in the entire body, changing all the inner correlation of forces and the form and nature of reactions. It ought to be clear to such a physiologist that during this quite imperceptible interval of time, approximately equal to one breath, a long series of complicated chemical and other processes are accomplished within the organism. The substance that has entered the organism is carefully analyzed, the smallest divergence from the usual is immediately noticed, and in the process of analysis, it passes through a series of laboratories. It is resolved into its component parts, and mixed with other substances, then in the form of these mixtures it is added to the fuel that nourishes the various nerve centers. All of this must occupy a great deal of time. The seconds, in our time scale, during which all of this is accomplished, make it a fantastic and miraculous phenomenon. However, the fantastic side falls away when you realize that for the large cells that obviously govern the life of the organism, our one breath continues for over 24 hours. In 24 hours, even in half the time or a third, 8 hours, which is equal to 1 second, it is possible to imagine all the processes that have been indicated being completed in an orderly manner, exactly as they would be in a large and well-arranged chemical factory, with various laboratories at its service. Passing further to the cosmoses of small cells that stand on the border or beyond the border of microscopic vision, we can again see an explanation for the inexplicable. For example, cases of almost instantaneous infection by epidemic and infectious diseases in general, particularly those where the causes responsible for the infection have not been found. If 3 seconds is the limit of life for a small cell of this kind, and equal in proportion to the long life of man, then what would be the speed at which these cells multiply, when for them 15 seconds would be the equivalent of 4 centuries? Passing to the world of molecules, we come face to face with the fact that within the brevity of the existence of a molecule, lies an almost unexpected idea. It is usually supposed that a molecule, although structurally very complicated, taken as the basics so to speak, is the living interior of the building blocks from which matter is built up, existing for as long as that matter exists. We are however obliged to part from this comforting thought. The molecule that is alive inside cannot be dead outside, and in remaining alive, it must, like everything living, be born living and then die. The term of its life equal, on our scale to an electric spark or to 1/10,000th part of a second, is too small for it to act directly on our imagination. So some comparison, some analogy is necessary in order to understand what this means. The dying cells of our organism, and their replacement by others bring us near to this idea. Dead matter, iron, copper and other minerals, must be renewed from within, more quickly than our organism perceives, In reality it changes before our very eyes. If you look at a stone, shut your eyes and immediately open them again, it will not be the same stone that you previously saw. Inside of it, not one single molecule that you saw the first time will now remain. Furthermore, even then you did not see the molecules themselves, but only their traces. Then in the last cosmos, that is in the world of the electron, we can feel from the very beginning the world of the sixth dimension. The electron, as a three-dimensional body, is too unsatisfactory, as to begin with it exists for 1/300 millionth part of a second. That is a quantity far beyond the limits of our possible imagination. It is considered that an electron within an atom moves in its orbit with the speed of 1 divided by a 15-figure number. Since the whole life of an electron in seconds is equal to 1 divided by a 9-figure number, then it follows that during its lifetime, an electron makes a number of revolutions around its sun equal to a 6-figure or, taking into account the coefficient, a 7-figure number. If we take the Earth in its revolution around the sun, then according to the table provided, it makes, in the course of its lifetime, a number of revolutions around the sun equal to an 11-figure number. It looks as though there is an enormous difference between a 7-figure and an 11-figure number. However, if we compare with the electron, not Earth, but the planet Neptune instead, then the difference will be considerably less, namely the difference between a 7-figure and a 9-figure number, that is a 2-figure difference instead of 4. Aside from this, the speed of revolution of an electron within an atom is a very approximate quantity. It should be remembered that the difference in the periods of revolution of the planets around the Sun in our solar system represents a 3-figure number because Mercury revolves 460 times faster than Neptune. The relation of the life of an electron to our perception appears thus. Our quickest visual perception is equal to 1/10,000th of a second, an electric spark. The existence of an electron is equal to 1/30,000th of 1/10,000th of a second, that is to 1/300 millionth part of a second. In that time frame it makes 7 million revolutions around the proton. Consequently, even if we were to see an electron as a flash in 1/10,000th of a second, we would not see the electron in the strict sense of the word, but only the trace of the electron, consisting of 7 million revolutions multiplied by 30,000, that is a spiral with a 13-figure number of rings. Or expressed in the language of the new model of the universe written by P. D. Uspensky, 30,000 recurrences of the electron in eternity.